Hi, I'm Vincent Wilczinksi. I'm the Deputy Dean at the School of Engineering and Applied Science at Yale University in New Haven, Connecticut. So what I do every day is basically keep the School of Engineering moving forward. Our program has biomedical engineering, electrical engineering, mechanical engineering, and chemical/environmental engineering. And as all of those separate disciplines have their areas of emphasis, we need to be moving in a common direction. At the undergraduate level, that common direction is the area of design, because design becomes the thread across all disciplines that moves the students from creation to applying the laws of engineering to actually product development. I think students have a natural curiosity to solve problems and to build things, to create things. That can be in the mechanical world, that could be in the electrical world. For our programs in biomedical, that's actually creating chemical processes, that's creating biological solutions to problems that actually exist. So the students come in with that curiosity. Now the role of the educator is to put in place mechanisms, projects, activities that harness that natural inquisitiveness, that natural desire to do something, and apply their knowledge along the direction of actually solving problems. So FIRST itself is an incredibly complex design project because they give students a challenge to solve in only 6 weeks to go from a blank sheet of paper to a completed automatically and remotely controlled robotic device that's 3 feet by 4 feet by 5 feet, 120 pounds, capable of playing mechanical sports. So to go from nothing to a completed device in a short time frame, in fact, is a very, very challenging design and manufacturing process. So the students do that by working as partners of engineering mentors to learn a design process, to come up with a solution to the particular challenge, and then actually to then manufacture, test, and compete with that device. The challenge to the team is to come up with an end result. Now to get there, they have to come up with initial ideas, some initial concepts, typically first done on back of an envelope, paper sketches, and then progressing to show their ideas in a form that can convey that thought, convey that system to other members of the team, and begin the process of actually building that device. So the whole design process comes from the idea creation. They have to come up with concepts, and then you go into the whole idea, the whole area of taking those concepts and picking one. Because as there's 14 different ways of solving this problem, we have to look at all those 14 and identify time is short, we need to go in this direction. So the best that you can do to convey your individual idea, the better chance that that one is going to win as the project solution. So being skilled in communicating, being skilled in conveying technical engineering information in a very apparent fashion is essential for the teams. How I first got interested in design as an engineering educator, it really is the component that takes the engineering fundamental theory and puts it into some type of real life form. So the interest actually came from finding ways of introducing students to the whole concept of open-ended problem solving, perhaps their first year in college, and then taking that concept and working it into engineering fundamentals class. So if we have a class on statics, how can this statics problem be applied in the real world? And so introducing open-ended problem solving within engineering fundamentals classes, so we have this continuum of design from freshman level, sophomore, junior, and senior. The senior is the capstone project, where students are given a real-world problem and actually have to solve it. So I think the teachers, there's a couple things, is that you're not alone. There's hundreds, thousands, millions of colleagues that are there for you to help. So if you reach out to your fellow teachers that have been active in this field, to get guidance, to get best practices. The other thing is that our professional societies are all very, very active in the role of K through 12 outreach. And if a teacher connects with a professional society in chemical engineering, electrical engineering, mechanical engineering, there's a wide variety of resources that are already available for them to get them going in this whole process. The one aspect of design that I think a lot of people don't really capture as much is that it requires the very detailed engineering underpinnings. So we can't design products without those engineering fundamentals, and you can't design products just with those engineering fundamentals. So there's really a marriage of this design aspect and these engineering fundamentals that I don't think are emphasized enough. And a number of approaches might be that, well, if we're very good on the engineering fundamentals, people will pick this up when they're in the marketplace. And it's too late then, because they don't have this history of how to apply the laws of Mother Nature to actually the design of products. Creativity is essential to the whole process because it's the genesis of these problem solutions. So whenever we're going to have to solve something, creativity is right there at the start, because how are we going to come up with that? We need to think of 14, 15 different solutions so that we can analyze them and go ahead and pick one. As we're moving along the process, creativity pops in at every step, at every level of the process. Even if it's communicating your design, there's a role for creativity. If it's trying to find a solution for a particular part of the problem, there's a role of creativity. That may be initial creativity, that may be looking at and using ideas from others, but there's always a need for new thought through the whole process.